All right. Hello, good morning, good evening, everyone. We're going to get started now. Thank you for your patience. My name is Eugene Cho. I'm a solutions engineer here at CircleCI. And I'm joined here today by Tom at Codecov. Tom, you want to introduce yourself?
Hey, yeah, I'm Tom. I'm a developer relations lead at Codecov. I help developers with their code coverage needs and how we can make Codecov a better service for all developers.
Fantastic. All right. So to give you a quick overview of what we're going to be going over today, we have just gone through a quick introduction. I'm going to be talking about continuous integration in general and what CircleCI is, followed by Tom, who will be talking about code coverage, what code coverage is, what is CodeCov. After which, we'll be jumping into a live demo showing how CodeCov works with CircleCI matrix builds, to which we'll be sure to leave some time for any questions that any of you may have for us. And if you have any questions, please feel free to use the Q&A function in Zoom, and we'll try to get to them, all of them at the end of this. Great. So jumping right in. What is continuous integration? So this is the first Google result from Martin Fowler, and I'm going to refrain from reading this out loud to you. I'm sure you can all read this. But basically, continuous integration is a way for teams to integrate their work frequently and in a way that makes errors more quickly catchable and in a way that promotes better quality of the end product. I'm going to keep kind of hammering away this as we go. So when we look at it kind of from an architectural perspective, what happens is you have a team of developers here on the bottom. Let me kind of put a pointer here, who may be working on the same code base and are pushing code into a version source control server, GitHub, Jenkins, Bitbucket, whatever it is that your team may be using. From here, the changes are pushed to a continuous integration server where the whole project is built, tested, and then you receive feedback on whether your tests failed or succeeded. If they failed, you basically get the notification that, hey, your code is broken, please fix it. Or if it succeeded, hey, great job, it succeeded, now you can move on to the next thing or even go on to deploying your code. Another way of looking at it, simply what CircleCI is, you're a developer, you push to GitHub, it goes to CircleCI, it fails, you go back to work, try to fix it again, push to GitHub, push to CircleCI. At some point, when you finally gotten you've done the right thing, you can push it to be deployed to wherever your production servers are, and then it goes to your happy customers who are happy to use your new features. All right. Another metaphor to look at this with is cooking is continuous integration. This is one of my favorite metaphors for what continuous integration is. And the idea of it is, instead of, let's say you're making a really fantastic, delicious soup, but generally when you're making a soup, you don't just put all the ingredients in all at once, wait an hour, and then eat the final product. Rather, you should be tasting as you go along to make sure that everything tastes right as you go along. And that way that you can make the small adjustments to make sure it tastes correct. And then at the end of the day, you end up with a higher quality soup and probably a lot less pain. And imagine it giving a scenario where maybe you added too much salt in the beginning. You may have to throw out the entire thing at the end and start over from scratch. And no one wants to do that. Okay, so now that I've had this amazing metaphor for you all, I'm sure you completely understand what continuous integration is. Thank you for coming to my presentation. Just kidding. So why exactly would you want to use continuous integration? This is all great, but why do I want to go to the trouble of doing this? So I have another metaphor for you. If you're all familiar with the Daft Punk song, Harder, Better, right? Harder, Better, Faster, Stronger. Pretty sure that's how it is. So when we break down the lyrics to the song, they're quite simple. You work it harder, you want to increase your test quality. You make it better. Increase the product quality. The end product is better at the end of the day. Do it faster. You can iterate more quickly on the work that you're doing because you're getting faster feedback. Make it stronger. You end up with more stable code at the end of the day because you're seeing it more often or you're getting the faster feedback more than ever, hour after. Fix bugs an hour after you make them, hopefully faster than that. At least having to wait a week and pick up where you left off. And our work is never over. You're going to do this continuously because writing software is a continuous process. So when we kind of look at it from the lens of commit to deploy time, let's look at it this way. Let's say it takes 15 minutes for you to build and run your automated tests, 5 minutes to build, deploy to staging, and then another 10 minutes for Q&A and spot check. This is a total of 30 minutes, and this can add up pretty quickly, when you're doing this several times a day. But having a really high kind of deploy cycle is kind of like having a long delivery cycle can be a drag on your entire team or your company, even in terms of whatever you're trying to push to your customers, right? If you have longer pull requests, or that means you have longer code reviews, which means you have worse code because not everyone has the time to read through your 1,000 lines of code that you just pushed up. Also means that you're going back to your work more infrequently, which is more context switching, which is more multitasking, which means that you spend more time picking up where you left off in the first place, which is a drag on your productivity. Which means you have less time, which leads to fewer features that you're able to work on, which means that's bad for your product's growth or your company's growth, which means you're unable to address as many fixes as you normally would, which means you have more churn in your customers. More churn means lost money. At the end of the day, continuous integration equals money. Simple. So to talk a little bit about CircleCI's mission, really boldly, we want to radically reduce the time between an idea and its release as production software. We want to make sure that developers are able to iterate as quickly as possible and take away a lot of that kind of overhead work of setting up your CI server or setting up your testing process, and give you more time to actually spend time working on those features that delight your customers. And we really believe that software delivery is a strategic advantage in every industry. It doesn't matter if you work in insurance, if you work in tech, you work in finance. If you're able to address bug fixes more quickly, if you're able to get more features to your customers, you're going to win. As far as where CircleCI fits in the ecosystem at a high level, we basically sit between creation and logistics. Creation being where your code is actually stored, GitHub, Bitbucket, Git, and then logistics being where your services are actually hosted, such as AWS, GCP, Docker, whatever it may be. We're right in the middle there, where we help you build, test, and deliver to production. Okay, so now I'm going to hand it over to Tom to talk a bit about the Codecov side.
Thanks, Eugene. That was so fantastic. I loved your analogies. And it's really incredible to see how useful a CI is, particularly one of such high quality like CircleCI. And having the right process can really ensure high code quality. And so that leads in well to what code coverage is all about. Now, the main problem that code coverage solves is, how do I, as an engineer, know that my code is well tested? So I know that when I'm writing out a new feature, I want to make sure that all of the functionality works. Or if I'm removing old code, I want to be sure that my critical code paths are still being tested. So what tools do I have at my disposal to be confident in the code that I'm deploying? And this is exactly what code coverage is meant to do. At a very high level, code coverage is a metric that lets you know what lines of code are getting hit during a run of your test suites. You can aggregate this information together as a single value, which represents the percentage of lines of code that have a test that executes against it. And this tells you two things. So first, it lets you see which lines of code in your code base are never run during a test suite. And second, it gives you an objective number of how well your code is being tested. So what does coverage actually look like? Well, this is an example from the Codecov UI, and I pulled up a file from one of our favorite repos, and this is basically what a coverage report looks like to a developer. It shows green lines, or lines of code that are being tested, red for missed lines, and yellow for partial hits, or when only some branches are hit in a conditional or maybe like a loop. But for most users, they care about this number, that 87.88%. Because at the end of the day, they want to know if they have maintained, increased, or decreased their total coverage. And so whether or not they have written enough tests, or they need to add more. So shouldn't that mean that 100% coverage is a good thing, that all of your code is getting tested against? Well, if you go on Reddit and do a quick search for 100% code coverage, you'll get hundreds of articles and comments talking about why you should or shouldn't. And the same is true for any other developer forum like Hacker News or Stack Overflow. If you talk to developers now, they're extremely opinionated about whether or not to have 100% coverage, although most of them will probably tell you it's not worth it. So I wanted to spend a little bit of time discussing the pros and cons so that you understand when it's necessary. So as you know, 100% coverage means that all of your code is tested. But more importantly, this means that all of your code also runs. Now, this is extremely useful because it means that there are paths to all of your code, which results in less dead code. It means that if you write new code, it'll help identify regressions. And it also means, as I'm sure many of you have experienced, that your syntax issues are resolved, that all of your semicolons are where they need to be, and all your variables are spelled correctly. But there's a lot of flaws with having 100% coverage. So writing tests for all your code is extremely time consuming. As an engineer, we estimate that writing tests takes almost as much time as the actual implementation. And code is never perfect. If it suits a particular use case now, it's highly unlikely to be suitable 2, 3, 4 years from now. And all of that to say that writing tests for edge case code can be extremely time intensive, so much so that the tests may be written for code that might not be relevant. And as you should know, a covered line of code doesn't mean that the test running against it is perfect. So with all that in mind, Codecov was built to help developers collect, display, and understand code coverage metrics. And that means we work diligently to ensure that the data we show is both acknowledgeable and actionable. And we do this by providing feedback as close to the developer workflow as possible so that they can find untested code and deploy their changes to production with confidence. Now, Codecov works by letting users automatically upload their code coverage reports, and we output both absolute and relative code coverage results. Now, this works for all metrics and coverage formats, and moreover, reports can be merged. But different parts of your code base can be flagged to give developers more information about the parts of their code base they care about. And we'll talk a little bit about that later. So in order to stay as close to the developer as possible, we post a comment onto a pull request with relevant data for the engineer, including which files are affected and by how much. We also show a status check, along with this one from CircleCI, to pass or fail a pull request based on an organization's coverage settings. For some, that might be 100%, while a new organization might only try to increase their coverage for all new code requests. And so whatever that number is, we make that as configurable as possible to work with your coverage goals. Now, we also provide line level coverage for users so that they can get granular information about each line of code that they're interested in. And this helps developers focus on what's important to them and ignore what doesn't matter. So if code coverage is this tool, how can I use it to better test my code? So we talked already about how hitting blindly for 100% coverage isn't always a good idea. And the reality of code is that not all of it is created equal. For example, I'm probably more concerned that my billing code is well tested as opposed to a small UI feature. And for the most part, this holds true across organizations. This is also exactly why we introduced flags a few years ago as a simple way to group coverage reports based on tests. So what does that mean? Well, for every coverage report supplied to Codecov, it can be labeled with a flag. And we'll see some examples shortly, but this could be flags labeled front end or back end or some other string. Now, a flag can be associated with multiple coverage reports. So you can upload 2, 3, 4, 10 coverage reports for the same flag. So instead of covering all of your code, we encourage our users to isolate code based on features or test systems that are important to them. So as an example of flag usage, we have a repository that has coverage reports for its backend and front-end files. In here, we see that the code base files have been split according to these designations. Now, this is really useful for projects that have, say, a really stable backend running Python or Go or Ruby, while their front end has migrated to a new framework like Angular or React or Vue. And in one case, the expectation is that backend code never drop below 60% overall coverage, while front-end code is expected to only increase over time because it's on a new framework. So separating the code base in this way with flags allows for more granular control of coverage and the necessary blocking of untested code via status checks, which we'll talk about later. However, we don't always need to split coverage based on the files. And in fact, many of our users have different test suites that they run on their code base on the same files. So in this case, a project runs separate unit tests and integration tests. In this example, we see that the unit test coverage is 100%. However, this user might only need integration coverage to reach the critical code paths. And for them, 80% code coverage is adequate. So flags can help separate the two types of coverage to ensure that integration tests are not inappropriately inflated by the results of running unit tests. Okay, finally, flags can be extremely helpful for users with monorepos. So in this example, we see that the main repository is split into 3 projects, call them Project A, Project B, and Project C. Now, these 3 projects can be completely separate from each other, working totally independently. And so as a developer on Project A, I might not know or care about the coverage metrics for Projects B and Project C. And displaying coverage for all 3 projects without flags isn't meaningful, as one project may be strict about their coverage and the others might not be as much. And that would lead to large coverage drops. So in this case, we see that Project B has really low coverage for whatever reason that might be. This would adversely affect the other 2 projects. So using flags on each module allows these projects to outline their own processes for adequate code coverage and determine when code can and should be merged in. Okay, so really quickly, in order to use flags with Codecov, you only need to update your codecov.yaml file for 2 things. And the codecov.yaml file is just a simple configuration file that we'll see a little bit later. First, you need to add the names of the actual flags. In this case, Project A, Project B, and Project C, as well as optionally, the paths that they include. So when you upload coverage reports to Codecov, simply add the name of the flag to the uploader and Codecov will do the rest, and we'll see that a little bit later. Now, for many cases, you might want to restrict coverage based on a flag. So let's again revisit this example of having 3 separate flags for Project A, B, and C. And we see that Project A and Project C have defined target values for the coverage of 95% and 75% respectively. So this means that if coverage drops below these values, Codecov will show a rejected status check on your pull requests. And this might be due to the maturity of their testing, so they expect new code to be well tested. But as mentioned, Project B may be new to collecting coverage metrics, and so they might only be interested in raising their target coverage, thus setting it to auto. So using status checks with flags in this way allows you to have the necessary restrictions on merging untested code. And with that, we'd love to show you a demo of how to use matrix builds and flags to make your processes and developments faster and easier.
Okay, so we're going to jump into the live demo. And what I'm going to go over today is showing how you can use matrix builds to quickly set up builds with a combination of operating systems and dependencies. And what we're looking at here, for those of you who are kind of looking at this kind of config file for the first time, this is a CircleCI config YAML. And this is where we store the configuration for how builds will run within CircleCI. And these are stored within the repository itself. So it's under source control. We're a big believer in infrastructure as a code. So this is a way to see how builds ran with each commit, basically. So what we're looking at here is basically I've outlined the executor that I'm running in, which is a Linux executor running a Docker image. This is a CIMG, is a CircleCI stock image that we use. It's a minimal image that we use as a base for other Docker images. And I'm calling it an orb. An orb is a prepackaged bit of config. It's basically a package of reusable config Here, particularly, I'm calling it a node orb, and this really kind of shortens or makes it a lot easier to call many different versions of node for this project. I basically have one job here in my workflow, and the job here consists of a checkout, installing different versions of node. I am then installing the dependencies of the project. I'm running yarn, run tests, and then I'm going to be uploading those coverage reports to Codecov. And here, what I'm trying to do is I am trying to test across several different versions of Node. So this is a Node.js project. And a couple of use cases that I think of when I look at this is particularly for open source developers, or if my team is trying to test compatibility across different versions. This is the way I would normally go about doing it is I would write this out, and a lot of this can already be done with the kind of standard 2.1 CircleCI syntax as it is today. We're able to do parameterized jobs, so you can pass in parameters to run jobs. And again, I'm in this workflow, I'm invoking this 4 times. So this is kind of what I'll call the old way of doing it, but just to show what this looks like, I'm going to commit these here. And if I go over to CircleCI, I can see that I've kicked off 4 different tests. These will all be the different versions of Node running in parallel with each other. And if I drill in, I can see that it started, this is the 10.9, 11.9, and so on, as I've defined here in my config. So we're going to be kind of building on this, but for now, I'm going to switch it back over to Tom, who's going to be going over some of the Codecov side of what's going on.
Awesome. Thanks, Eugene. Okay, so to kind of explain the code in this project so that sort of makes sense as we talk about it throughout the rest of this demo, I'm going to go over the code, and then I'm going to go over the changes in the CircleCI config so that it kind of makes sense on how to actually upload coverage reports to Codecov. So in this code base, I set up 2 subfolders under source called index and calculator. And so we'll take a really quick look inside, but they're pretty simple classes. For index, we have 3 functions. And the first one is only going to run part way of the if branch. And the second and third are always going to return true. But the last one is actually not going to be tested, as we'll see in a little bit. Now, going into calculator, we have a simple addition and subtraction function. And so we'll spend most of our time actually looking at these functions. But for now, let's go over to the CircleCI configuration so that we can see how to upload coverage reports to Codecov. Awesome. So this should look familiar, as Eugene has pointed out, but I want to kind of focus here between lines 28 and 30. So we see the step upload coverage reports to Codecov. And it calls this bash script, which actually does the uploading of the coverage report to Codecov. And this F flag here actually denotes a flag name, which we talked about a little bit earlier. So for simplicity, we named the flag based on the CircleCI job. Now, because demos are always a little bit flaky, I made a PR which adds in the subtract code that we saw a little bit earlier for the calculator class, but it doesn't actually test this function. So if we go to this PR, we see that Codecov will reply to the pull request with a comment showing the coverage has decreased, and it shows you by how much, and how it affects any flags that you might have, and finally, all the files that have a coverage change. So let's click on this file and see what actually happened. So clicking in, you see that the shaded green area here shows the code that I have added, the subtract function. And the solid red shows that these lines aren't being tested. So this makes it really easy as a developer to figure out why my coverage increases or decreases and where I might be missing test coverage. Now, since uploads are tied to commits, I'm going to go to the commits tab here and click on the most recent commits and inspect the coverage reports that were uploaded up here in the builds tab. So we see here that each coverage report has a flag associated with the CircleCI job. Because of the configuration early, well, we said that the flag name would be associated with the CircleCI job name. And we can use this tab to view the build or to review any of the raw reports themselves. With that, I'm going to shoot it back over to Eugene, who's going to show you a little bit more about how to use matrix builds.
All right, great. Thanks, Tom. So what I'm going to do now is I'm going to start building in some of the matrix features of CircleCI. So instead of having these 4 lines, as I showed earlier with the different node versions, I could actually rewrite this using the matrix keyword and adding in parameters for this. And here, oops. I can pass in the node versions as an array. And I'm going to say 0. And I will just copy paste the rest of this because I'm sure no one needs to watch all this. So now I have different node versions and I can get rid of these lines. And here I'm basically just duplicating or replicating the work that you just saw earlier. This should be really no change to the end result of the builds. So now I push a change. If I go back over to CircleCI, I can see that these tests are all running. Here, the only difference is that I've actually, using the parameters, they've been tagged in a human-friendly manner, so I can actually see what versions are being run in each one. So before I had enumerated 1, 2, 3, 4, I can actually see the versions that are running. Okay, I'm going to switch it back over to Tom now to go a little bit more on the Codecov side.
Great, thanks, Eugene. Okay, so what I didn't get to talk about last time were status checks. So let's go to the codecov.yaml file, which holds the configuration for this project. Now you'll see here under coverage and status that there are 2 values, project and patch. Now project coverage is defined as the overall project coverage. It means that in the entire project, what percentage of lines are actually being covered. Now we see that the target is 20% and threshold is 1%. So what this means is these values state that the coverage on the project cannot drop below 20% being the target. But we give a 1% wiggle room for potentially flaky tests. So what this really means is that the true lower bound for coverage is 19% for this project. Now patch coverage, on the other hand, measures the coverage of all new code changes in a PR. So right now we've set it off, we'll turn it back on for the next part, but which means that it's not going to pass or fail a particular pull request based on relative coverage. So again, going into a pull request that I made, we see a status check for the project and it's at 71.42%. And it's above our target of that 20%, thus passing the build. I'm going to switch it over back to Eugene now, who's going to show you some more awesome things to do with matrix builds.
Unmute. All right, here we go. So now what I'm going to do is I'm going to turn this into, add basically another dimension to this config. So now not only do I want to test across different versions of Node, but I'd also like to say test in both Linux and Mac OS operating systems. And I'm able to easily do that here by adding in the by adding in OS and saying I'm going to test this on Linux and Mac OS. And I need to make a few changes to the config above. So what I'm going to do is where I've defined what my executors are, I'm going to define what my Mac OS one looks like. And that is using the Mac OS executor. And I like to use Xcode version 11.4 for this. I also need to add additional parameters. So whereas I've already had the, so we look at this here. I already have a parameter for node version, and now I need to turn this executor into a parameter as well. So here I'm going to say OS is type executor, and the executor itself is parameters. We'll be calling it parameters.os. Great. So by making those changes there, I should see basically the Cartesian product of this running. So I'll see the 4 different versions of Node running in Linux and the 4 different versions of Node running on Mac OS as well. And if I hit commit on this, and hopefully I didn't mess up the typing here. Oh, looks like it went through. So now I'm able to see in a really human-friendly manner, again, that all these are labeled with different versions and different operating systems they're running on in the Cartesian project in easy to read manner. So this really works with any set of parameters. You're not limited to just OS and node. It's really not a finite group at all. You could really use anything that can be used as a parameter to define these matrices. And this is just basically scratching the surface. We're able to also use, you can use exclusionary combinations, or you could use templated dependencies to create much more complicated workflows than what I've shown here. And that's all available within our documentation. Great. So I'm going to switch back over to Tom now to kind of wrap things up on the Codecov side.
Awesome. Thanks, Eugene. Okay, so flags are a really cool way to take advantage of matrix builds. And set up properly, you can use flags to understand coverage based on backend or front end, or by software versions, or in this case, by operating system. So taking a look at the CircleCI config again, we see a little bit more complexity here in the steps that are run. And so I decided that we only want to run the index tests on Mac OS. And while we want to run the entire suite for Linux, and we've also used that separation between Mac OS and Linux to view flag coverage based on the OS, and we'll see what that looks like in a bit. Now going into the Codecov.yaml file, we see that we have two new status checks, Linux and Mac OS. And this is going to help us pass or restrict a coverage report based on those flags. Also, it means that we can isolate the important systems in our code base to ensure that they're heavily tested. Okay, so I'm going to go into the pull request, and we're going to see here that the Mac OS status check fails. Oh, sorry. Because it hits a lower coverage target than expected. Now, again, as we saw in the Codecov.yaml file, we're expecting 100% coverage, but here we only see it by 85.71%. Now, we can go into the Codecov UI to better understand why this is happening. So I'm picking the index.ts file because it's being tested by both Mac OS and Linux, because they both run tests against it. And something interesting that you can do is you can play with the toggles here to see what happens with the coverage overlay, like so. So again, as we mentioned, both of them cover this file. So if I untoggle both of these flags, we should see that nothing is being covered. And you'll see that that's true. And I should also see that if I only toggle one of them, that the coverage overlay shows up. Now, of course, this is a pretty simple example, but if you have a complex system with integration tests that only run for critical paths, while unit tests cover the entire file, this will really help differentiate and show you what parts of the system that you are testing for those critical systems. Awesome. With that, thank you so much. We really appreciate you all being here. We're going to move over to a live Q&A session. And I'm going to leave this summary slide up just so you're aware of the things that we talked about. And if you have any more questions, we'd be happy to take them.
I'll read out for you how about some of these questions that are on Codecov, and perhaps we can go back and forth actually, but we'll start with a Codecov specific one. How do you check coverage against the patch in Codecov patch section in PR status? Is it for module or specific diff?
Okay, so the patch coverage, and just to reiterate what patch coverage is, if I'm making a pull request and I'm making some changes to files, what I'm most curious about is for the code that I'm adding or removing or editing, does the coverage change? Is all my new code being tested properly? So that's what patch coverage is. So you can do this by looking into the actual Codecov UI to take a look and see what code you've actually added. So that was in the example that I gave before, where you saw the light green lines on the side, which distinguishes what code has actually been added. Now you can also get this in a status check, which I think I had up in here. But as you saw in the third stage that we were doing, that I re-enabled patch coverage. And so all of my new code for this particular PR is being tested. And you can actually set a target as well. So the target was set to 83.33%. And now that we see that all of my new code has actually been tested.
Great. Okay. I'll take this next question here, which is, can you explain a little bit about how CircleCI would work with multiple PRs for the same lines? How can it help developers when there are conflicts? So when it comes to multiple pull requests on the same project, basically, whenever there's the default behavior is that whenever there's a pull request on a project, that will get triggered, it'll trigger a build basically on CircleCI. There is an option in project settings in CircleCI to basically auto-cancel any preceding pull requests that are still running. So if you have, for example, a build that takes 20 minutes and there have been like 3 pull requests in the span of 10 minutes, 5 minutes, let's say, those earlier 2 can be canceled, so you can kind of save on your usage basically when you get there.
And the question was, can we upload our own coverage report on Codecov, which I generated using another tool? So for instance, Golang test can generate a coverage report. Can I use that on Codecov? The answer is absolutely. In fact, that is pretty much how Codecov is going to work. Now, of course, we can run gcov using the bash uploader, but for the majority of other languages, Python has coverage.py. We see that they'll create their own coverage report that gets uploaded to Codecov. And so we'll take those reports, we'll merge them, and we'll make them easily accessible to developers in order to make sure that they understand what the code coverage report actually is saying.
Let's see, there's a question here on, does CircleCI and Codecov also work with Kubernetes? So I guess we'll both answer that. But on the CircleCI side, I guess it depends on what you're trying to do with Kubernetes. There are kind of different pieces to that. So if you are trying to deploy to Kubernetes, that's generally something we can do. If you're trying to spin up a Kubernetes cluster and then run CircleCI within CircleCI's environment, that's currently not possible. If that is kind of what your question is aiming towards, that's kind of a solution that we are working towards. I guess we should expect to see something around that by the end of this year in terms of actually one of the major features that we're working on currently is kind of hybrid model where so basically what I presented today is kind of like the SaaS model. So we're providing CircleCI services as software as a service, but we have an alternate model that we're working on, which is basically allowing customers to install and run the build agent on their infrastructure. So it could be on a Kubernetes cluster, it could be on any type of machine or smart machine, it could be a fridge or watch, whatever it is, and then basically report those and use CircleCI Cloud as the orchestration tool and your reporting tool.
I was going to say, this answer is going to be a lot shorter. I'm not super familiar with the intricacies of how Kubernetes works with Codecov, but we do have users that do run Kubernetes and also Codecov as well. So it does work, to answer your question, but I'm not completely sure about the engineering details of implementation there.
Okay. This question hurts for me to ask you, but does Codecov integrate with other CI/CD tooling, including native Azure, AWS CI/CD?
We do. Now, of course, we love working with CircleCI, and we've worked really well with them. But we do integrate with a majority of other CI/CDs.
Hurts me to hear that. I'm just kidding. Okay, so let's go to the older ones. In coverage report, what do white lines signify? They sometimes appear in between code instructions, apart from imports.
Yep. So the white lines typically specify what lines of code aren't typically considered worth covering. And so an example of that might be like a blank line. It might be an end bracket. And so those things aren't typically considered lines that are important for coverage. Now we do some special things with different languages. So I know we'll try to compute what these white lines should be for Ruby. But for the most part, it typically leads to things that aren't necessarily useful for the developer.
Last question on here from now. Given a monorepo for a stack that is managed by one team, can module coverage be merged such that you may not have a unit test covering a line in a shared module, but that same line is tested/covered at the integration level?
Give me a second to sort of parse this question out. So you're
saying
it's
a doozy.
Yeah, so you have a monorepo and it's managed by one team, okay? And you have a module coverage be merged such that you may not have a unit test covering a line in a shared module, but that same line is tested at the integration level. I mean, I believe so. The way that I'm sort of thinking about this is that, do you have a unit test for a particular line, and do you not have? Oh, sorry. I guess it's the other way around. Do you have a unit test that isn't covering a line and an integration test that is covering that line? And yeah, that answer is definitely. And so I think like it really depends on how you're doing your testing. If it's more important to you that integration testing actually covers your entire code base and runs through all of your code paths, then you'll see coverage be fairly high for integration tests. And if you run a flag for unit test, and let's say that you haven't ever done any unit testing and you just decided, hey, like we should probably do unit testing as opposed to just integration testing, then you would see those lines in a shared module not be covered. Eugene, which CD for Kubernetes do you recommend when I'm using with CircleCI, Argo or Flux?
Well, it's a great question. I've heard really great things about both solutions and others. At CircleCI, I think the philosophy really is to be as tool agnostic as possible. So we really try to make it such that, the way I like to think of CircleCI sometimes is, here is a build machine, do whatever it is that you want on it, except build, mine for Bitcoin. So basically, if there's an API for it, then it'll work on CircleCI. So it really, I guess, depends on whichever tool that you find to work better for you, and they should both work generally on CircleCI. And if they don't, please reach out to us and let us know what is not working, because we'll try to get that working. Okay. All right, Tom. Are Codecov flags only based on folder structure? In my project, sometimes integration tests and unit tests are located in a single folder. Is there a way to distribute them into two flags?
Absolutely. In fact, that's a really common case. And if you guys remember from that slide that I had earlier that showed backend versus front-end coverage and unit test versus integration test coverage, it is really common to have these tests run on the same files. And so flags are actually mapped more towards the coverage uploads as they are compared to the folder. Now, the folder is more useful from the perspective of a user and being able to say, oh, great, like this flag is only for these particular folder directories and subdirectories, as you would see with a monorepo. But that's not necessarily the way it has to work. So if I have integration tests running and if I have unit tests running, you can set it up so both of them will produce their own coverage report. And what you would do is you would upload each coverage report separately. You would do it separately and you would name it with the flag name that would be interesting. So for integration tests, you might say -f space integration. For unit tests, unit tests. And that way you can have both of those coverage reports being reported on the same files, but not necessarily have them interfere with each other.
Okay, looks like there are no open questions, so I am going to assume that we are okay here. Great. Anything else, Tom, you wanted to add?
No, it was great to be able to talk about CircleCI matrix builds and Codecov flags. It's wonderful to see how well that they can work together to make a better developer experience when you're pushing and when you're trying to test and when you're deploying code. So really happy to be able to talk to you all about this. Looking forward to see what you do with these amazing features.
Yeah, likewise. Thank you, Tom, for your time and joining in this presentation. I think I learned a lot about code coverage in general and how the tool works. So you guys have a really, really awesome kind of product over there. I'm looking forward to kind of
Thank you.
use that in my future projects to make sure I'm writing tests that I never do. Um,
Same for you, Eugene.
and
We love using CircleCI, and I didn't know about build matrices before we did this webinar, and they look so cool. It was wonderful being able to build out this demo with you and see how flexible and how easy they are to understand.
Fantastic. Well, it's great to hear. Cool. Okay, so we are going to leave this on for a couple minutes and then close up this presentation. But otherwise, thank you everyone for your time and joining today. I hope you all learned something new or interesting today. I hope to see you soon for another webinar. Bye all.